Okay, let's unpack this. You know when you're watching a movie with a robot and the skin just looks, well, fake. That entire problem might be solved very, very soon.
We're doing a deep dive today into some genuinely astonishing work coming out of the University of Tokyo. For years, the big roadblock for realistic robots has been making their surfaces feel and act alive, their mission, to give robots skin. And I don't mean synthetic skin.
Right, not like silicone or some advanced plastic.
Exactly. We're talking about skin made from actual living human cells. And the real bombshell here is that this skin, it actually heals itself.
What's fascinating here is the foundation of it. It's not just, throwing some cells onto a surface. It's a very specific bioengineered system.
So what is it actually made of?
They're using the core building blocks of our own skin, sourced directly from human cells. We're talking about collagen and fibroblasts.
Okay, collagen and fibroblasts. Break that down for us. Sure. Think of the collagen as the scaffolding. It provides the structure. And the fibroblasts are like these tiny little construction workers in your skin, constantly building and repairing tissue.
So that combination is what makes it a truly living system.
That's exactly. And that's what gives it the ability to heal from, minor cuts or scrapes.
I have to pause on that, though. How do you convince living tissue to permanently stick to a hard synthetic robot mold? That just seems impossible.
It's a really brilliant structural trick, actually. The surface of the robot's mold isn't smooth at all.
Oh.
It has these very specific V-shaped perforations, little holes.
Like tiny anchors for the cells to grab onto.
Precisely like anchors. It gives the living cells something to hold onto and start building a stable, bonded layer. That structure is what supports the tension and growth.
That attachment mechanism alone is just mind-blowing. But here's where it gets really interesting for me. This technology has to be applicable beyond just making, ultra-realistic facial expressions on humanoid robots.
Absolutely. While making those mimic robots more realistic is definitely application number one, having viable biological tissue outside of a body unlocks at least two massive fields.
Okay, what's the first one?
First, it gives us an incredibly accurate and ethical testing medium for cosmetics.
Right, so you can test products on actual human skin biology without relying on animal testing or synthetics.
Exactly. It's safer, it's more effective. And the second big one, it completely changes how we train plastic surgeons.
That makes perfect sense. Instead of practicing on inert rubber mannequins.
It's a world of difference. This bioengineered skin reacts realistically. It stretches, it holds sutures, it provides authentic feedback.
So it's invaluable experience before a surgeon ever works on a real patient.
Invaluable. And if we connect this all back to the bigger picture, the team in Tokyo is aiming for maximum biological realism.
So this is just the beginning, the top layer of skin.
That's right. This is basically the epidermis. Their future goals are far more ambitious. They're planning to add highly complex biological structures.
Like what?
Like adding pores, for one, and integrating things like sweat and sebaceous glands.
Wait, sebaceous glands? The ones that produce oil?
Yes. And they want to incorporate blood vessels for color and warmth, and even fat and nerves.
So the final robot skin would actually feel and function just like yours. It would maintain moisture and have a natural sheen.
That's the end goal. A complete functioning organ system on a machine.
So what does this all mean? The pace of realism is just accelerating faster than I think anyone thought possible. If we can give machines self-healing, functional skin that sweats and reacts to touch, what are the ethical and practical boundaries of realism that you need to start considering next?